Hi everybody, come let's go with static VR compensator. In recent years, a reactive compensation of charging power is made feasible with the application of three-phase thyristor and power control circuit with automatic control function. The term static VR compensator is applied to a number of static VR compensation devices for use in shunt reactive control. These devices consist of shunt connected static reactive element, that means linear or non-linear reactor and capacitor configured into a VR compensating system. Some possible configuration are mentioned, even though the capacitor and reactor are connected to the low voltage side of a down transformer. The capacitor bank may be distributed between high and low voltage buses. The capacitor bank often includes in part harmonic filter which prevent the harmonic current from flowing in the transformer and the high voltage system. Filters for the fifth and seventh harmonic are generally provided. The thyristor control reactor, that means TCR, is operated on the low voltage bus in another form of the compensator reactor connected to the secondary of a transformer. The primary winding is star connected with neutral grounded suitable to the thyristor network. The secondary reactor is normally non-existent as it is more economical to design the reactor transformer with 200% leakage impedance between primary and secondary windings. The delta connected tertiary winding will effectively compensate the triple harmonic. The capacitor bank is normally subdivided and connected to the substation bus bar via one circuit breaker per sub bank. The regulator generates firing pulses for the thyristor network in such a way that the reactive power required to meet the control objective at the primary side of the compensator is obtained. The reactor transformer has a practically linear characteristics from no load to full load condition. Thus, even under all strained over voltages, hardly any harmonic content is generated due to saturation. The transformer core has non-ferromagnetic gap to the required linearity. It has some following requirements are to be borne in mind while designing a compensator. First one is reaction should be possible, fast or low whenever demanded. No switching of capacitor should take place at that time to avoid additional transient in the system. Then commutation from capacitor to reactor and vice versa should be fast. No switching of the capacitor at the high voltage bus bar so that no higher frequency transient is produced at EHV level. Elimination of higher harmonic on the secondary side and blocking them from entering the system. Then in three-phase, the thyristor controlled inductors are normally delta connected as shown in to compensate unbalanced loads, and the capacitor may be star or delta connected. In the thyristor controlled reactor, the inductive reactance is controlled by the thyristors for a limited range of operation. The relation between the inductive current and the applied voltage is represented across the figure. So the inductance is varied. The susceptance varies over a range within the limits BL minimum and BL max corresponding to XL max and XL minimum, while the voltage changes by V volts. Let's see the next explanation of unbalanced load of SVC. The current flowing in the inductance would be different in each half cycle. varying with the conduction angle such that each successive half cycle is a smaller segment of a sine wave. The fundamental component of inductor current is then reduced to each case. Quick control can be exercised within one half cycle just by giving a proper step input to the firing angle control static VR compensator. When installed, reduce the voltage swings at the rolling mills and power system buses in drive system applications. They compensate for the average reactive power requirements and improve power factor. Electrical arc furnace impose extremely difficult service requirements on electrical power system since the changes in arc furnace load impedance are rapid. Random and non-symmetrical three-phase static VR compensator can be located independently so that it compensates for the unbalanced reactive load of the furnace, and the thyristor controller will respond quickly in order to minimize the voltage fluctuation or voltage flicker seen by the system. Thus, the furnace characteristics are made more acceptable to the power system by the static VR compensator. The application of the static VR compensator to an arc furnace installation for reactive power compensation at the HP bus level. It has some types. The types of SVC or variable impedance type, current source type, voltage source type. The following are the basic types of reactive power control elements which makes all are parts of SVC. Saturated reactor or thyristor control reactor, thyristor switched capacitor, thyristor switched reactor, thyristor control transformer. So it has some application of static VR compensator. That applications are connected to the power system to regulate the transmission voltage, that means transmission SVC, then connected near large industrial loads to improve power quality, that means industrial SVC. Thank you.